The Earth is about 12,760 kilometers in diameter and about 150 million kilometers away from the Sun. The nearest stars besides the Sun are about 4.3 light years away. 1 light year equals 9.5 times 10 to the 12th kilometers. At a scale of 1 to 10 billion, the Sun would be about the size of a grapefruit. How big and how far away would the Earth be on this scale? How far would the nearest stars besides the Sun be? For this particular problem, we need to go ahead and understand that these distances that are being given to us are extremely huge. And we notice that this particular distance right here is given in scientific notation. And we'll write this first number down because we are going to compare this number at some point. But this is the distance to the nearest stars. We're also going to look at the fact that the Earth is about 12,760 kilometers in diameter, and we'll write that as 1.2760 times 10 to the 4th power. Then we're going to talk about the Sun. The Sun, as we stated, is 150 million kilometers away from the Earth. So we use 150 million kilometers, and we're going to write that out as 150 million, and then we're going to convert that into scientific notation. And in scientific notation, we'll have 1.5 times 10 to the 8th power. Now remember that these are all in terms of kilometers. And I need to put down kilometers for the Earth. And the last thing that we're going to look at before we start to do the problem is that is a scale of 1 to 10 billion. Well, 10 billion looks like this. And if we go ahead and put that in scientific notation, we will have 1 times 10 to the 10th. Now, the first question asks approximately how big would the Earth's diameter be on this scale. One of the things we'll notice is that since this is a multiple choice problem, the units that are given in our answers are either millimeters or centimeters. And what we're going to do is we're going to use a conversion factor. One of the conversion factors will be the fact that 1 kilometer is going to be equal to 100,000 centimeters. And in terms of scientific notation, that'll be 1 times 10 to the 5th power centimeters. And that's my conversion factor. And I can go ahead and write this as a ratio of 1 times 10 to the 5th centimeters to 1 kilometer. And this is what we're going to use to multiply by to find our actual information. I also want to point out for this problem that 1 kilometer is equal to 1 million millimeters. Once again, if I go ahead and use scientific notation, that's 1 times 10 to the 6 millimeters. And that would be compared to, once again, 1 kilometer. So I need both of these since my possible answers are either in millimeters or centimeters. So the first thing we do is we take the Earth's diameter, which is 1.2760, and we're going to divide that by the scale of 1 to 10 billion. And since 10 billion will be equal to 1 times 10 to the 10th, we're going to put that right here. So just to clarify, this is Earth's diameter. and this is the scale. What you're going to do is you will take this 1.2760 and you will divide it by 1, which will yield 1.2760. We're going to multiply that by 10 to some power. And that some power will be the fact that we take the 4 and we subtract 10 from it. I'm just going to write this here. 4 minus 10 will be equal to -6. Okay. Now remember that that is my scale. Okay. It's still in kilometers. And we want to go ahead and multiply that by one of our two conversion factors. Either this one or this one. We'll start with conversion factor A, which is converting it to centimeters. And I will have 1 times 10 to the 5th centimeters divided by 1 kilometer. Notice that for this, the units will cancel out, this kilometer and this kilometer, which means that my answer is going to be in terms of centimeters. And when I set this equal, I find that I'm going to multiply the 1 times the 1.2760, and that will give me 1.2760. And that's going to multiply these two terms, or factors I should say, multiplied together. But when you have like bases of 10 here, I simply add the exponents, and I'm going to have times 10 to the -1 power. And that's going to give me that will give me 0.12760 centimeters. Now we'll notice that that particular answer does not exist either here or here, so I can go ahead and discount them. Notice that the value is right here is 1.2760, and that's the key to the problem because that rounds to 1.3. And we'll know that that is in millimeters because I'm going to take the same exact value, this right here, which is 1.2760 times 10 to the -6 kilometers, and I'm going to multiply that by the conversion factor for millimeters, which is conversion factor B, and that is going to be equal to 1 times 10 to the 6th power in millimeters divided by 1 kilometer. Once again, the kilometers will divide out, and I'm going to be left with 1 times 1.2760, which will be equal to 1.2760. And I'm going to multiply that by 10 to some power. And that power is going to be easily calculated when I multiply this value times this value. Remember, if the bases are the same and you're multiplying, you simply are going to add the exponents. And I have -6 plus 6, which is 0, which means that I'm looking at times 10 to the 0 power, which is the same thing as saying 1.2760 millimeters. Notice that the only possibility will be this answer right here, 1.3 millimeters. This part B wants to know how far apart or how far away would the two objects be on this particular scale. So we're going to be looking at the distance between the two objects. That's going to be from the Sun to the Earth, which is 150 million kilometers. we'll go ahead and take that and convert that to 1.5 times 10 to the 8th power, which we have right over here. And that's kilometers. Okay. And we're going to go ahead and divide that by our conversion factor, which in this case is 10 billion. So that's going to be 1 times 10 to the 10th power. And that means that this particular value right here is simply going to be equal to 1.5 times 10 to the negative 2 power. Now, what factor is that going to be in? Well, that's in kilometers. And if I look very carefully, I don't have a 1.5 kilometer option. I just have a 1 kilometer. So that means it's either going to be in terms of meters, centimeters, because those are the only other two choices. I got meters and centimeters, and this is meters again. So we'll take this 1.5 times 10 to the negative 2 kilometers, and we will multiply it by conversion factors. Since we've already disallowed kilometers, we'll go ahead and look at meters. Well, I don't actually have a conversion factor here for meters, but we can create one fairly quickly. We'll also notice that 1 kilometer is equal to 10,000 or 100,000 meters, which is, sorry, that should have been 1,000 meters. So the conversion factor that we're looking for here is going to either convert it from meter into meters or into centimeters. But one thing that I want to point out is you'll notice that there's a 1.5 here, and this particular value and this particular value do not match. However, this one does. And if I look at the conversion factor for meters, which is 1 times 10 to the 3rd meters, I'll bring that over here. We have 1 times 10 to the 3rd meters, and that's over 1 kilometer, because that is our conversion factor, because as I pointed out in both this case and this case, A and B, it was over 1 kilometer. Now I notice I didn't put the 1 here, so I'll just go ahead and write that in. So when I do this, I'm going to have 1 times 1.5, which is going to be equal to 1.5. And then I'll have 10 to the negative 2 times 10 to the 3rd. And we'll see that the negative 2 plus 3 is going to be equal to 1. So I have 1.5 times 10 to the 1 meter, which is going to be equal to 15 meters. And that will give me my answer right here. Which brings us to part C. Approximately how far would the nearest stars beside the sun be on this scale? So once again, we're going to pull in and look at our scale. And here's our scale. So remember that this right here is going to be the distance from our sun to the nearest star. Okay. And that's the thing that we're going to concentrate on. And then this is the scale. So we'll go ahead and we'll take the nearest star, which is 9.5 times 10 to the 12 kilometers. And then we will divide that by the scale, which is 1 times 10 to the 10th power. And that's going to give 9.5 times 10 to the 2nd power kilometers. But this is for 1 light year. Remember that the nearest sun or nearest star is 4.3 light years away. So we'll take the 4.3 and we will multiply that by 9.5 times 10 to the 2 kilometers. And when we multiply this out, we end up with 40.85 times 10 to the 2 kilometers, which will be equal to 4,085 kilometers. And that will round to approximately 4,100 kilometers, which will yield this answer, and we have finished the problem.